We want to spend a little time looking at just some basic threading on its own. Threading is pretty simple implementation in that we can separate it out from the behavior that we need to actually execute otherwise. It's something that we can add over the top of it, but we've got to plan it ahead. So let's look at the threading by itself. Then we'll come back to the application we're trying to build and go from there. So let's start with a basic Java application here. So basic Java application, and this is thread demo. We'll just do some basic, interesting little threading here. So one of the things about creating threads is I have to create a class to encapsulate it. You remember, I have to have a thread class or a runnable to make that happen. Which way you go is really immaterial on how you're going to do your work. So I want to do it the way you most likely should do it, because we don't need to build a type of thread most of the time. We just need to build some instruction set. So this can be, and we'll go back to the example we were doing there, the counting, and we'll make it a runnable here, just so it's really clear what we have going on. Now, this runnable class, most importantly, needs to implement runnable, control space. Alright, so the runnable interface out there, you can see it's java.lang. It's actually don't even need to import anything here. I'm just using control space to be able to complete it out there. And in NetBeans, then I have to go back and add the run method. There's two ways I can do it. I can type it out myself, or I can hit Alt Insert and say implement method here, because it's implementing an interface. So I can say implement a method, and I can pick from that list, and hitting spacebar here, the run method. Alright, so now I have the run method as part of my runnable. And this is all the work that's going to be happening as part of my runnable. Now, the counting method was pretty simple. I can say for int, oops, sorry, I put my parentheses inside of there. Int I is equal to 0, I is less than, we'll say, or equal to 100, I plus plus. So we're just counting from 1 to 100 there, and we'll do system.out.println I. So we'll count 1 to 100 here. Alright, that's real basic runnable inside here. Now it's not a thread. It's just a runnable. I still have to create an instance of this. So it's, at this point, just like every other Java class. In order to make it into a thread, I have to sneak it into the threading mechanism. Not really sneak it in, just added it. It's probably more accurate. So if we go back to our main class, the first thing we need is an instance of this object. So, oops, I need a counting runnable. Control space. And this is the counter. And create a new counting runnable. Now, as I said, this is just a regular class. Just to show you what the basic behavior of this is, I can go to counter.run. There's nothing special about this method in that it has to be executed by a thread. It can be executed by anybody. And as we talked about, you can see I count. Well, it started at 0 here, and then I go up to 100. So if I don't want to go to 0, by the way, I can just change that to 1. So I want to count 1 to 100. It's a bit more common. We don't normally start counting at 0. All right, so I can call this method at any point. It takes no data in, it receives no data back, but that's okay. It still is a method. It's not a thread, though. If I try and run this twice, it runs it both. It runs it one time, then a second time. So if you look at the execution here, you can see it counts 1 to 100, and then it goes and counts 1 to 100 again. It's kind of like reading books. I don't read 2 books at the same time. I read the first one, then I read the second one. Okay, that's what we have going on here. Now, if I want a thread, I have to build a thread object. Since I implemented runnable, the counter is not a thread object by itself. I need to create a separate thread for it to run. And honestly, it sounds like extra work. I like that. I like that behavior because it differentiates what's the thread versus what's the instructions. It adds that extra layer of separation. It gives us a little bit additional obvious intent that's going on inside here. But again, there's nothing wrong with having extended thread. So the thread class here, then, I can do control space on this just so you can see. Oops, here, control space. There's the thread class java.lang. It's part of the basic Java language package, and so it's automatically imported for us. I don't have to add any more imports. We'll just call it thread t is equal to new thread. Control space, and we can see there's a number of constructors here. And so the one that we want is the one that gives us a runnable target. Now we can name the thread, we can give it a runnable target and name the thread. Naming the thread helps you basically in logging later on, be able to look at it later on. Thread groups helps you manage the threads. That's not terribly important. What we want to have inside here is a runnable, and since NetBeans is pretty clever and helpful, it actually picks the runnable instance that's right here, and it plugs it in as the variable. Now, if I say t.run here, this does the same thing as what what we would be doing before. So I can actually say t.run twice. If I run this before, it runs 1 to 100. You can see 1 to 100 here, and then starts over and runs 1 to 100 there. This is just calling the run method. It's actually calling the run method on thread, which then calls the run method on counter. We can actually go to the debugger and see that jump through if we wanted to, but I'm not going to worry about it right now. What we want to do instead, remember, is t.start. When I say t.start, then it runs it as a thread. Now, I can't tell any difference. You see, it just runs it 1 to 100. One way I can tell the difference here is if I say counter.run. Let's say I ran the same class, the same object, call that method another time, right after I start the thread, then all of a sudden it's going to behave a little differently. So I say run, and at this point, you can see it starts counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It counts up, counts up, counts up, counts up, counts up. Oh, nope. Actually, that ran back to back. That one ran back to back too. Okay, let's see. Let's just see. Let's try it again. If it does it again. Oh, that one did back to back as well. Oh, no, I'm sorry. No, it didn't. There you go. This one didn't do it here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 19. And there you go. Now it starts 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It goes up to 100. And then the other one takes over at 20. Okay, so there you go. The thing about threading is you never get the same results every time you run it. So the first time it ran all of one, then ran all the other one. This time it ran one and it switched it over. That's if I run it again here. Up there you see right there it runs 161. So they are interspersing back and forth. Now it's really hard to see how it's interspersing. It's really hard to know what's going back and forth, but you can see one of them goes up to 7, and then the other one takes over at that point. And it goes up to 60, and the other one takes off and goes to 8, and it goes up to 9, up to 100, and then the other one goes back to 61. So this is the behavior we want to see. This is the back and forth behavior. But again, it doesn't give us much flexibility. It doesn't give us much option. It's always counting 1 to 100, and I have no idea which one's which because it's doing the exact same code without any customization inside of there. So let's take a look at how we can add some customization into our thread class, our runnable class more specifically, that would allow us to change the behavior a little bit. Because really what we want from object orientation is the ability to tweak back and forth different behaviors that each object can behave slightly differently. When I create a Tony object, I have a different name than you, as whatever your name is another person object that's out there. That's the whole idea of objects, is I customize each one with its own data. So we'll come back and look at that in a second. Take a moment and build this code, though. Get this part of it running. Get this part of it built, and then come back and then we'll expand on it from there.